Today we'll be talking about the law of sines. You may recall in geometry that you worked quite a bit with the Pythagorean theorem. So a squared plus b squared equals c squared. However, Pythagorean theorem only worked for right triangles. What about all of the other types of triangles? So what we'll be doing in this section is looking at something that you can use for any oblique triangles. So this would be triangles with no right angles. Remember that we always label triangles by their angles, capital letters A, B, C, for example, here, and that the side lengths opposite to those angles, so side length A here between B and C, would be little a because it is opposite of angle A. Same thing for B to angle B, and then C to angle C. So when can you use law of sines? You can use law of sines whenever you have one angle, its opposite side length, and then one other piece of the triangle. So that could be another angle or another side length. And when you do law of sines, you use the following. A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. You could also do this in reciprocal form with sine of A on top over little a is equal to sine of B on top over little b is equal to sine of C over little c. And what you'll do is you'll look at the information that you have, and you want, as I mentioned, one angle and its opposite side length. And so if you have a and little a, for example, then you'll use that with whatever piece you know from either B's or C's. Let's do an example so it's a little clearer as to what I'm trying to say. Let's take a look at this triangle. We've got triangle ABC, and I'm given the following information. Angle C is 102.3 degrees, so I've marked it there as such. Angle B is 28.7 degrees, right there. And side length B is 27.4 feet. So the first thing I do, if it's not given to me, is make a triangle and fill in the information that is given. So I've marked angle B here, 28.7 degrees, side length B across from it, 27.4, and then this angle measure for C, 102.3. This is great. I have an angle, I have its opposite side length, and then I've got one other piece, this triangle. So I note that I have both parts for B, angle B, and side length B. So I'm going to start with the sine of B over little b. This is equal to, and then what else do I know? I know the angle measure for C. So this means I'm going to use B's and C's. So this will be the sine of C over little c. Okay, let's fill in what we know. This is going to be the sine of 28.7 degrees over little b is 27.4 feet. This is equal to sine of angle C is 102.3 degrees. So this will be sine 102.3 degrees. And what's unknown as of right now is side length C. All right, we are going to solve for C here. That's the only unknown out of these four. So let's cross multiply. That's going to give me C times the sine of 28.7 degrees. This is equal to 27.4 times the sine of 102.3. degrees. All right, solving for c, we're going to divide both sides by the sine of 28.7 degrees. All right, c is equal to, let's bring up our calculator here. Note that we have to be in degrees because we're working in degrees right now. So if up in your calculator, this right here says radians, then you'll need to change the mode by clicking on mode, going down to radian or degree, and then switching over to degree if you're in radians, and then you can clear this. Okay, so once we're in degrees, let's go ahead and plug in what we have over here. This is 27.4 times the sine of 102.3 Okay, so that's 26.771 roughly. And we're going to divide that by the sine of 28.7. Okay, so I find that C is roughly 55.747. We can call that 55.75. Okay, what else is missing? You can fill in here. This is 55.75. I am still missing angle A and then side length A. Well, a way to find angle A here is remembering that all three angles in a triangle have to be 180 degrees. So if I know the other two, then I can say 180 degrees is the total minus the angles that I know. So this angle is 102.3. And I'll also subtract the other angle that I know, 28.7. So this means angle A must be 49 degrees. Okay, and I can write that here. How I found that was I said 180 degrees minus 102.3 degrees minus 28.7 degrees. This gives me A is 49 degrees. All right, lastly, I have to find side length A. So with my law of sines, sine of A over little a is equal to sine of B over little b is equal to sine of C over little c. I'm going to use the A's because I'm missing part of my A's. I'm missing the side length. So this tells me I will be using the sine of A over little a will be equal to, and then it doesn't really matter which way I go. I can use B's or C's here. Since I was given the angle for B as well as the side length for B, that's probably safer to use just in case I am incorrect in how I found C. So let's do sine of A over little a is equal to sine of B over little b. Okay, let's fill in what we know. This will be sine of 49 degrees over unknown A. This is equal to sine of B, so angle B is 28.7 degrees, over 27.4 feet. All right, same thing here. I'm solving for A, that's my only unknown. Let's cross multiply. and I will get A times the sine of 28.7 degrees is equal to 27.4 times the sine of 49 degrees. All right, let's divide both sides by the sine of 28.7 degrees to solve for A. A is equal to, in your calculator, let's do 27.4 times the sine of 49 degrees. And then divide that by the sine of 28.7 degrees. So side length A is roughly 43.06. I'm comfortable just saying that's 43. I believe this was in feet, so if it asked for units, it would be 43 feet. So we'll go back up here, and we'll put in, this is 43. All right, let's do one more example. Let's say I'm given this triangle. So this is ABC, and the information I have is side length A is 22 inches, side length B is 12 inches, and angle A is 42 degrees. So I go ahead and I make a triangle, and I fill in the information here, and I note that I've got an angle and its opposite side length. So perfect. This allows me to use a law of sines as long as I have one other piece of the triangle, so either a side length or an angle, which I do here. I have B is 12 inches. So this tells me that I'm going to use law of sines where for sure I'll be using the A's. And then because I know one part of the B's, I know the side length, I'm going to be using the B's to find angle B. So let's begin with sine of A over little a is equal to the sine of B over little b. And the information I have is A is 42 degrees. So this will be the sine of 42 degrees over sine length A is 22. This is equal to sine of B, so that's unknown, over side length B is 12 inches. Okay, I've got one unknown out of these four. We're going to cross multiply. This will be 22 times the sine of B is equal to 12 times the sine of 42 degrees. All right, then I want to solve for B. B is inside of this sine, and then it's multiplied by 22. So let's divide both sides by 22. And this will be the sine of B is equal to, in my calculator, we'll do 12 times the sine of 42 degrees, and then divide that by 22. Okay, so this is 0.36498. Let's capture as much of that as we can. So this would be 0.36498. Note I left some space here. That's because I haven't solved for B yet. B is trapped right now inside of this sine function. So I need to do the inverse to undo the sine function and let just b be itself. In order to do that, I do the sine inverse. But what I do to one side, I have to do to both sides. This sine inverse will undo this sine, leaving just b. So b is equal to, in the calculator, to get sine inverse, you're going to hit second. And then now, instead of sine, when I press this will be sine inverse of 0.36498. So this is roughly 21.4 degrees. Okay, what's left to find? We have to find both parts of C, the side length as well as the angle. Now that I know two angles, though, I can use the fact that all three of these angles must be 180 degrees. That's their sum. So I can say 180 degrees minus 42 degrees minus 21.4 degrees. Let's see what that gives us. 180 minus 42 minus 21.4. This is 116.6. So angle C must be 116.6 degrees. And lastly, to find side length C, I can use law of sines again. For sure, I'll be using C because I got one part, but I'm missing the side length. And then I can use either A's or B's. Again, just to be sure that I'm going to do this correctly, or rather, in case I made an error in finding angle B, I'm going to use A. So let's do sine of A over little a is equal to sine of C over little c. Let's do that over here. All right, let's fill in what we know. So this will be sine of 42 degrees over 22 inches is equal to the sine of 116.6 degrees over some unknown value for C. All right, let's cross multiply and solve. So this will be C times the sine of 42 degrees is equal to 22 times the sine of 116.6 degrees. Divide both sides by the sine of 42 degrees. And we will find C is equal to 22 times the sine of 116.6, and we'll divide that by the sine of 42 degrees. All right, C is 29.398. Let's just call that 29.4. All right, that is the law of sines. Hopefully that helps you out. If you have any questions, please let me know.